Hey everybody, happy Monday. Okay, made it through another week. Now we're starting a new one. It's Monday. Hey, thanks for people that braved down to campus. I know it's cold out, but it's sunny at least. It's all good. Thanks for joining us remotely. As always, we are recording this so you can catch up afterwards. Tonight, we're going to be talking about continuous integration. We're also going to see a little bit more unit testing and just sort of get a better feeling for what the build process for your project is all about. You've already been experiencing this clearly as you've been working with the katas and the koans and your project one. But now I want to kind of take a peek behind the curtain at what's going on there, and talk about some of how GitHub Actions can help provide rapid feedback on the changes that we commit in. So we'll be doing that. And of course, we'll also talk about Project 3 tonight. But first, I wanted to open up the floor for the things that are on your minds. It's been a little while since we were together. I posted some things on Slack this weekend. There was a little bit of engagement. But Project One is due on Wednesday, and I want to check in with everybody. So maybe we can start with Project One. How are things going? What are you experiencing? What would you like to know? What can I tell you? Yeah.
Let's do well. Doing a ton of, you know, trying out test-driven development has been like, you know, um, a little challenging at first, just getting used to that like mentality.
Test-driven development is different, isn't it?
Like, you know, like just making tests for those, but also like thinking about like also like creating my own as well.
Yep.
So it's been like I don't know, it's just been kind of clashing a little bit with how we usually program. But I think that yeah,
Yeah.
I think I'm almost done. I just have to do like crazy test works like like I guess input that like I wouldn't
Yeah,
expect.
boundary test. That's like the fancy word for it. Yeah. I like crazy test better. And the word clash. I like to put how you put that. I mean, it is a bit of culture shock to go from the way we were all taught to program, which is like think about your solution and do it, and oh yeah, maybe test it afterwards. To like, oh wait, let's put the test first. And it sounds like right now it's a little awkward for you, and I'm curious about as we go week over week as you do more of it. Does it start feeling more natural? Is it just awkward? Is it just, okay, fine, can grin and bear it? Or do you decide to, abandon it altogether and then write your tests afterwards, which I wouldn't recommend, but it's, something you can do. I'm not gonna know either way. Um, but yeah, but good. Thanks for sharing those experiences. And I bet you're probably not alone in that. Other folks on Project One, questions that you have on your mind, any feedback you want to give me on, what you've been doing so far and what it's been like? Yeah.
Not really feedback, but I do have a question. Why are we doing like this kind of overlap thing where project one gets
Haha, yes. Okay.
project two, project three, and then their due dates come in?
Okay, so then yeah, so yeah, the sequence of the course yeah might be a little unusual where yep you have on paper 2 weeks to do every project, but look a new project is assigned every week. I do that for a couple of reasons. I want to give you more than a week to do the project. I think as you saw with the koans, it helped to have a couple of weeks to get started there. And there's so many weeks in the term, and I also you know the for me, there are some meta lessons in like every class that you want to take. And one of them is managing your priorities and managing your time. And so then I don't think I'm being unkind, but the reality is that, yeah, I kind of want you to figure out, hey, how do I balance, what I've got in front of me with what's coming next? We were talking about it a little before class, and yeah, I'll be talking about Project 3 tonight, which of course, for all of you, yeah, it seems way in the future, but I want to give you an idea of what's coming next. There's a lot of stuff that I want to cover, and the years have shown us that we can cover all of this. But you're right. There are sort of like now that we're getting to the middle of the course, it might feel that there's a lot going on because there is. But yeah, I'm glad you picked up on that. It's purposeful. I don't really have a better way of doing it because I don't want everything to come crashing down in the end of the term. right? Because I mean, all your other classes will be heating up by then. Of course, you'll know the most at the end of the term, but I want you to be able to have the foundations in place to be able to, you know, enjoy, almost even savor, the Android project. So you're not feeling rushed with that. And also with the web project, people find like, oh, wow, this is pretty cool. There's a lot of moving parts. And, I don't want people to feel that they're rushed. And so that means it puts back pressure on the beginning of the course.
Gotcha.
I'm glad you pointed that out. Thanks. Yeah. Other things for Prime Minister's questions before we dive into the content. Yeah. Yeah.
I noticed that was the phone bill DAO is also
Yeah.
in the testing. Do we like constant out in there? Because like, if we're only doing, was it, the phone call, the phone bill is probably once, right?
Yes.
That would be counted, but yeah, but the DAO is also being counted for this. So I was wondering if that is worried about that.
Excellent question. And before I provide the full answer, the DAO is new this term. So we'll be talking about it, in a couple of weeks. Yeah, when we talk about Project 4, that's the JDBC, that's where the DAO comes from. You'll learn about all those acronyms mean in a little bit. And so then just the same way, as you'll see when you start working on Project 2, there are examples of how to get started with your text parser, your text dumper. I wanted to have an example in there with the DAO just to make sure that everybody can access the relational database it's created. So that's why it's there. I also pointed out that it's new because, boy, I hope it doesn't mess with anybody. We've never done that thing before. So if anybody finds the DAO is getting in your way, actually, there was a question about it that I think I reposted it. Let me know. Because as you point out, it is another class. It is code that needs to be covered. I think there's already sufficient coverage for it, so it really shouldn't count against you. But if you get to a point, it's like, listen, I've got like 72% coverage, and I can't, the reason I can't get to the 75 is because of the DAO. Okay, maybe that's a cue to, like you said, comment out some code because you're not using it, right? Delete it all together and recreate it. I'm not sure, but yes, do let me know if you find that it's getting in your way, and so then I can, advise on how to work around that, and then, provide either a better or better covered example in the future. Yeah, smart. Mm. Okay. Here, oh, let me check the chat. But hearing nothing else, yeah, nothing in the chat. Oh, Zoom's in dark mode now. Okay. So, um, I hope you had an opportunity to review the Maven lecture before class. So you've all been using Maven since pretty much day one of the course, maybe the second day of the course. Maven is a build system, and um, my guess is that based on the experiences of students in the past, that you probably haven't really worked with something this complex. You probably worked with makefiles, right? And makefiles are great and makes complete sense with C. But they're just not sufficient for Java, and they're certainly not optimized for Java. And so Maven came along as an improvement over Make and a couple other predecessors, to provide a common build system for Java applications, in particular Java, open source Java applications, where you're just building a library and putting it out there on the internet. But we use it in this class for the projects that we build, even though we're not publishing artifacts anywhere. It works really well because what it does is it gives you the life and complete life cycle of your code, right? You learn in the lecture about the various phases of Maven, where you compile your source code, and then you compile the unit test for it. You run the unit test, and all these phases are successive, right? And so if any one of them fails along the way, there's no reason to run the rest. So if your code is compiled, don't even bother compiling and running the tests. And then, once your unit tests, pass, then you move on to building the jar file, and then you run the integration tests against it. And when we start talking about when we get to the REST API, you'll see that Maven can be used to do things like stand-up testing environments, like start a web server and deploy your deploy your web application to it, and then run integration tests against that. It's a really powerful tool because it has this whole plugin infrastructure. And so what Maven provides is a build system for your project. And it's a build system that's really part of the source code, or that's what's there in the pom.xml, which you've probably seen a little bit of. It describes the project. And I was going to say it says how to build it. I'd say it more describes the project, and then what Maven does is because it's declarative, it uses the POM, which is declarative. It just says, okay, great. I know how to put all that stuff together. I know how to build the test, run the plugins, do all the stuff. And so tonight we're going to see some more things that Maven can do, but we're also going to talk about how Maven plays into continuous integration. So actually, is continuous integration a topic that's been covered in other courses? Have you learned about things like Jenkins and stuff like that? Okay, I'm seeing a couple of nods and stuff like that a little bit. Maybe seen it like in a project that you've worked on, or if you talk to someone who works professionally. It's for me. Even though I guess it now seems like gosh, this just makes sense. Hasn't it always been this way? No, it wasn't always this way. So when I started my career, maybe the more mature development organizations had something like Makefiles, but a lot of the time, especially for a newer language at the time, like Java was, um, people had shell scripts for building the code, and maybe you shared that shell script with other people and maybe you didn't, and so then we ran into this really peculiar problem, where the actual like software artifacts that were produced and shared with others and maybe even like shipped to the customer were like run on people's desktops, and the environment wasn't necessarily consistent. And as a result, you got really, weird bugs, and you had, oh yeah, no, that works on my machine. Don't know what your problem is. And so we didn't have reproducible environments. Um, and nor did we have standard build pipelines. So uh, one of the things that people figured out in fairly short order, once we started having standard build tools like Maven, is that they said, wow, wouldn't it be great if I had like an automated build pipeline that would kick off yep, would kick off as soon as a commit is made or a commit is pushed to my source code. It would automatically take that new code and integrate it into the build. And so what these continuous integration tools do for you is that it builds your source code, it builds your project, your application, in a clean room environment. And in these days, what that starts with is provisioning a brand new VM. So totally clean, right? So you don't need to worry about like what's been run there before. Brand new VM, brand new file system, has all the tools that you need to build it installed. And it goes through the sequence of events. It checks out your source code. It runs your build script, so your Maven in this case, or whatever you're using. Um, and monitors it along the way, and so if it fails, it will alert you, but it can take all but it can make all of the steps of your build. So compiling the source code, running the tests, running analytics on the code, looking for maybe third-party libraries that are vulnerable, generating reports about where potential bugs might lie, all of this great stuff. And publishing these artifacts, like the reports, and of course the artifacts generated from the build yourself, like your jar files or your web application or whatever it is that you're doing, but publishing that to a shared an artifact repository that then can be used by other people to consume. So it may be if you're building an open source project, the continuous integration would publish to Maven Central, but more likely for commercial software anyway, where the artifacts aren't public, it's published to an internal repository so that it can then be those artifacts can be consumed by other projects and ultimately bundled into other software. So that's conceptually what continuous integration is all about. Providing a build that is repeatable, that is clean room, is agnostic, and so you don't have the problem of having a build machine that has all sorts of changes to it that you don't understand, have lost track of, and can't reproduce. Continuous integration also provides you with very rapid feedback on your change, right? I love rapid feedback, right? You get rapid feedback in unit tests. Of course, you get rapid feedback from your compiler, from your IDE, right? And the reason that rapid feedback is so important is that it allows you to work in small increments and you find bugs, you want to be able to find your bugs as soon as you introduce them, right? And we've all been there. You code for too long or you go too long between, running your tests and you broke something and you have no idea when. And you have to go back, sometimes hours and sometimes days too, if you're not careful, to find out it's like, oh, right, I have an equals where I should have had a not equals, or oh, hey, I've got an arithmetic logic error there that I didn't find right away. And, you know, it takes so much longer. What is all this stuff? It takes so much longer it takes so much longer to go back in time and figure things out as opposed to like getting immediate feedback and then you can sort of say stop the presses, fix the bug, and then continue on. So, and continuous integration will alert you when there's something wrong. And so then also you can, not just things are wrong with like, oh, your code doesn't compile, your test fails, but then you can also have it run analysis on your code, on your artifacts. And, then again, blow the whistle if like, oh, look, you just, upgrade to a version of a new version of a third-party library, and it's got known vulnerabilities in it that are really bad. Oops, you don't want to do that. And it lets you know these things as opposed to having to find them out, much later on. And by automating all of this, it makes it a lot less error prone. And so you're not relying on the work of a human to manually go through and build things, compile them, and copy them off into the right place. Hey, let the robots do all of this. They're very good at it. And so as a result, you go faster because you find out you find your bugs sooner, and you have the courage to go fast. Because it's like, hey, listen, I'm going to commit my small chunk of work and have the machines go off and do all this evaluation and let me know if there's something wrong. Meanwhile, hey, I can I can go on to the next thing. And if I do get feedback that something's broken, great. I don't have to go back in over the last however long your build takes 5 minutes, 15 minutes, hopefully not much more than an hour, so that you can go back and fix what you need to fix. So as a result, you get new capabilities out to your users, which is exactly what we're here to do, right? Solve real problems that are meaningful to people. We can do that as fast as possible. We want to do that as fast as possible. And hopefully what we provide them is so compelling and so awesome that they pay us money for it. And that lets us continue our mission and do more stuff. It's a great virtuous cycle. So anyway, that conceptually is what continuous integration is all about, and I think I kind of already covered this. So it goes through this whole pipeline of checking for changes to the source code repository, or maybe the source code repository actually will trigger will trigger a build after the commit has been made. And then when a change in the source code has been detected, it builds things. So again, gets the latest source code, runs a build process, which includes automated unit tests and analysis, all this kind of stuff, creates the artifacts that other people want to consume, publishes them out, and that's it. So that's conceptually what continuous integration is. Let's actually look at it in practice. So the continuous integration that we use in this course is built into GitHub. And it's a really nice feature of GitHub. In many other cases, there's a separate. So it's cool that that continuous integration is part of your repository. A number of people use GitHub Actions in practice for open source projects or even for their closed source world. But very often you'll see that there is a separate server or a separate service that does your continuous integration builds. One of the very popular ones, especially in the Java ecosystem, is called Jenkins. It's basically a server that you run or either run in your on-premise environment or in the cloud or whatever, and you configure it to go look at your source code, and then it's the thing that will go off and do the build. But conceptually, they work pretty much the same. But as you can imagine, there's some amount of configuration that you need to do. And for GitHub Actions, there is a .github directory in your source code checkout. And some of you might have encountered this already, and I'll talk about some of the signs that you might have seen. But there's .github directory that has a workflows subdirectory of it. And then there is a file called maven.yaml.yml. And so this is how you configure GitHub Actions to, well, take an action, respond to changes in your repository. Now, the syntax here isn't super important. It's not you're most likely never going to write one of these for this. Well, you're definitely not going to write one of these for this course. But I just wanted to walk through and sort of highlight some of the things that you can configure with regards to GitHub Actions. So, yeah, you can give your action a name, which is nice because it'll show up in reports and stuff like that. And you need to tell it when the action should be triggered. And so I have this action triggered on two things. When there is a change, when there's a change pushed to certain branches. So when you've got a change that's pushed to the main branch or any branch that ends in dash snapshot. So then, the rest of the stuff will happen when there is a change to one of those branches. Or when you make a pull request against, again, those same branches. So either, the main branch or the dot snapshots. And actually, it was in the GitHub lecture. Are you all familiar with do you know what a pull request is? Can I tell you more about that? Okay, that seems a familiar concept. We'll actually see one here in a bit in GitHub. But the whole idea is that, hey, you've got one branch that has some changes on it and you want to put it into another branch, usually your main branch that's shared with everybody. You create a pull request, even though it should really be called a merge request. But anyway, a pull request into the other branch. You're giggling about merge request? I know, right? Yeah, yeah. It's like, yeah. So that basically says, hey, listen, this is when the action is triggered, and then here's what you do. So, these so-called jobs are run, and there's a build type of job. And you can specify also information about this build that happens for your source code. So the first thing is that you specify what operating system you want it to run. And the cool thing about GitHub is it has this whole, it has this ability to create this whole fleet of VMs supporting many different operating systems. And while Java, it probably doesn't make too much of a difference because Java's platform independent. If you're building native code or you're building, an app or something, it's like an iPhone app or an Android app or whatever, yeah, you need to, specify certain platforms. So then I just, choose the latest Ubuntu. Why not? And then you can configure information like, hey, these are the versions of Java that I want to test with. And there are changes in between different versions of Java. And so one of the nice things you can do is you can have this build matrix, which says, hey, great, do the build once on Java 21 and in parallel also Java 24, just to make sure there's no difference in them. It makes it super easy. And then you can assign each build a run. That's basically dependent on the version of Java that you're using. And then, do I need to update these? Is it saying is that no? Okay. And now, so you've said, okay, great. Here's what operating system I want to run it on. Here's what version of Java I want to use. Now, here are the actual steps of the build. And so, the first thing you do is you check out your source code. And GitHub knows all of this because it's a GitHub repository, right? So it knows what version, what URL to check out, essentially, what repository to check out. And then you set up Java, and so then the GitHub Actions knows how to download the appropriate version of the Java development kit, install it in the right place, can configure the environment to do Java things. And then finally, there is the command that you use to perform the build, which is invoking the Maven wrapper, just like you do on your command line. So, you tell the build system, you tell the continuous integration server, yep, after you have gotten the source code and configured the Java environment, then you can run Maven. And really, that's what you all did on on day one, right? In your own environment, you get the source code, you configure Java, you build Maven. And so this makes it really easy, though, to do this automatically in response to a change. And oh, I don't know, I just add some optional arguments like batch mode so that the ASCII is nicer, and so it fits better in a log file. And we'll see how all this works shortly. Then you can also specify the pom.xml that you go to run. So that's the maven.yaml file. That is the configuration for the continuous integration build. Before we sort of see how all of this works upon on a commit, anything else I can tell you? Any thoughts lingering in your mind about sort of the fundamentals of continuous integration or GitHub Actions? Yeah.
The scale files specify what to do when you like push. How do you specify how like seems like this is this going to like notify your failures or something?
Yes, excellent. Yeah, so great question. So it's like, okay, if something goes wrong during the build, what happens? You'll get an email about it. It'll be available in also it'll be available to see in GitHub, and actually we'll see that pretty shortly here. Maybe that's what we should do next. Just introduce a failure. Great question. Anything else though that we can talk about before we move on? Okay. So this enables the continuous integration build. Let's make a change and see what happens. So you remember the student test? Let's see here. I want to write a failing. Here's what I want to do. I want to write a failing test, and I'll check it in, and we'll see what happens when the build fails. So let's see here. We have string contains GPA, string contains student name. Let's say let's have one that is oh I don't know. Void negative GPA. Let's see here, GPA, no. Throws invalid GPA exception. Great. Okay. So then let's see here. That's all good. Oh, I don't like that. It wasn't very smart. But we need to create the invalid GPA exception. I'll create that as an inner class of student. Yep. And let's see here. I gotta get this right. Let's see here. Do I want to extend throwable? I don't want to extend throwable. Let's have it be a runtime exception. Nice. Okay. And let's say maybe static. That's cool. Oops. Nice. Okay. I don't like the way it structured this code though. I want to use assert throws instead. Throws. Yes, please import that method. And then I want to say this lambda. Oh, was it going to new student? Come on. It just like teases me where it's like there it was again, right? And it's like as soon as I move the cursor, I just want to move this. It's like I don't know. And then oops, did I get this wrong? Oh yeah, you say the name of the class type first. Have you guys? I can't remember. Did we talk about cert throws already? Kind of. Let me just go through it again. Um. So okay. So we focused on well, we did some happy path tests, and then we did some other other tests. But throwing exceptions is part of an API. It's an important part of an API, and you want to be able to test that. And so then if you remember what the code was like before, the AI generated code said, great, try to create the student with an invalid GPA and then wrap it in a try catch block. And if the exception is thrown, great, just return. Otherwise, make an assertion failure. Yeah, that was the old way of doing it, but JUnit 5 introduced the assert throws. Method throws assertion that basically says the following, assert that a certain type of exception is thrown, in this case, an invalid GPA exception, when the following code is invoked. And here we use a lambda expression, which you probably saw in the koans, and the lambda lecture is coming up here. But basically what this means is that, hey, here's just some code that's invoked. But it's code that you can send to a method as opposed to just code that lives outside of a method call. So you basically use the syntax where you start out with parens, and if there were any arguments, those would be the arguments, but they're not. And say, great, create a new student with an invalid GPA, and we'll assert that the exception is thrown. Now, one of the nice things about assert throws is that it returns the exception that was actually thrown. And so here I can then say I can assign that to a variable. And let's see here. And then since I have the exception that was thrown, I can then ask it information about itself. So here I'm going to extract a variable. Extract a variable. I'm going to call it, no, I don't want that. Oh, I want to put it in the containing block. Yes. I'm going to call it invalid GPA. And then, so not only am I going to, not only am I going to assert that how many do you want to assert that? Not only am I going to assert that the exception was thrown and that the message for the exception, contains that invalid GPA, but I also want to assert that the exception itself has a get invalid GPA value, invalid GPA method that yes is equal to the value that I put in. This is a very common thing, right? The exception itself knows what valid wasn't what value was invalid. And this can be very helpful in an API to be able to have that information. So I'm going to add that there too. So I'm going to create a read-only property. I like that. Yeah, so that creates a field and a getter on that class. That's cool. And this is going to be a double. Nice. Okay, so this is how you can use I think it's a little bit more readable. This is how you can use assert throws with the invalid GPA, and then after you not and here when you can assert that not only was it thrown, but then you can get the exception and interrogate it and say, hey, do you have the state that I expect? So I'm going to run this test, and it fails. Great. Now, for the purposes of demonstration, I'm going to check this code in, and we're going to see what happens. So this is interesting. It looks like I have upstream changes. I have incoming changes. I wonder what those are. I wonder why I don't have them here in my repository. So what I'm going to do is I'm going to do update project, which will also do a git pull. I usually just do an update project. That'll get some changes that are coming in. I wonder what those were. What did I change? Oh, maybe that's something else. Did Spencer commit some stuff to the repository? Interesting. Maybe that's wrong. Git log. Spencer, did you do some implementation in, am I working on your repository? I very well may be. Sorry about that. I wonder I might totally have the wrong repository. Nope, no, wait, let's double check that. You shouldn't have push permission to my repository. So no, I think what I'm doing is I think I was helping you and I got to check out of your code. Nice. Sorry, everybody. Okay, so then, oh yeah. And since they're both called the same thing, let's see here. Where's my? Yeah, totally. Sorry, Spencer. I'm not gonna. Okay, I'm glad I didn't commit to yours. I should have checked a little sooner. Great. So I will just add that stuff there, and then I will go find my changes to student, and then add this to the bottom. Wah, wah. Okay, here, and then go to student, add these to the bottom. There we go. It's better. Yeah. Oops. And then, yep, go back here, revert all my changes. I didn't commit anything, so it should be okay. And I'll close this. Hee hee. So, yep. Nope, that was all on me, Spencer. Don't worry about it. Should be all right. Okay, so now let's try this again. I will run my method. Yep, it fails because expected an invalid GPA exception to be thrown, but nothing was thrown, right? Because we didn't actually, go from red to green yet. So now that I've got this, I want to, I don't think I need these changes. Oops, I'll revert them. Oh yeah, I was helping somebody else without that. Revert everything in the koans. Student changes. Sweet. Okay, so introduce a failing test to see what happens with continuous integration. So I'm going to commit this and oops, I'm going to commit this and push it up to GitHub. Commit and push anyway. There we go. And now over here in my browser, let's go to GitHub. And we don't want the cause repository. Actually, we want, what was that? Joy of coding. Almost. Joy of coding winter 2026 is what we want. Nice. Okay. So, oh, good. Here is the commit. So I'll make that a little bigger so people can see it. Here is the commit. And there's this little like amber dot over here. And this, and both this and also what's here in the actions is your continuous integration. So I'm going to go to actions section and oh, look at that. Yeah, I've got some red. It looks like I've actually had some red since January 14th. I should have checked in on that. So maybe I already had a failing build. But look what happened. So here is when I make every time I make a commit, every time I push to the repository, this build happens. And when this build happens, I get this thing. So it said, oh, this was triggered via a push a minute ago to the main branch. It lets you see what changed. But then it tells you that there were, two jobs that were completed and they both failed. And it looks like JDK 24 failed and then it canceled the 21 one because it's like, listen, if one's failing, why bother running the other? And so now I can scroll past a whole bunch of stuff and basically it runs actually, let me go back to the top. It runs, this is the output of the continuous integration build, and it corresponds to those actions that we created in the YAML file. So if I go back to the maven.yaml, right down here in the jobs build section, I have these steps. So I check out, I set up a Java environment, and then I run Maven. And I've got these names here. Well, those names are then in here in this view of the job. So this is where we set where we go and check out the source code. And so you can see it doing all of that. And here's where we set up Java, and we can this is where it goes and fetches it from Adoptium. That's nice. But the most interesting one is your build output from your Maven. And so here it's running the Maven command line, and then it goes through and shows the output of Maven. Now, because it's a clean room environment, it downloads all the artifacts every time. So I remember, if you remember the first time you ran Maven and downloaded, let's see, half the internet. Well, this downloads half the internet too, because it's a clean room build, which is, exactly what you want. But now there's a whole bunch of stuff to look at. So I'm then going to scroll down to the bottom and scroll up to back where everything. So we're running Maven, and we are compiling tests, and now we're running the tests, and now we now find that it fails because with the exception that we expect. Invalid GPA exception wasn't thrown where we expected it to be. But you got all of this for free because you use GitHub Actions. So, this actually, what this does is it, saves you from yourself. Hey, maybe you weren't careful enough and didn't run all of your tests or whatever. Don't worry, the robots are doing it for you here in continuous integration land. So this shows up, it's quite visible if we go back to, sorry, if we go back to the main repository, I just need to go back in the browser here. So, we go back here, and you can see, actually, if I reload, yep, now there's a red X there saying there was a failure before it was still in progress and now it failed. And so then you can see it here. Oh, and when you click on it, it'll give you a little bit more detail and you can navigate back to where we were before. Um, and it associates it with that commit. And so then if someone else looking at this project and said, "Oh wow, when did it start failing?" You know right away, and so that way you know what changed, and so it's much easier to go and remediate it once you know when it changed, and also you know who it changed because because GitHub tells you who made the commit. So that's really to answer your question, Ed. It's like that's what happens when the build fails. It shows up right here. You also get an email, sent to you. GitHub's nice enough to, send an email to the people that that either signed up to get failure messages or especially the person that introduced the change. So some of you have probably gotten these emails. As a matter of fact, you probably all have. So okay, yeah, nodding, and so. Sorry if it's confusing or whatever at first, but the whole idea is like, hey, if you push up something that makes your build failed, you'll want to know about it. And so then out of the box, GitHub will notify you about that. Makes sense? Anything else on your mind? Anything else that you'd like me to tell you about continuous integration? Yeah.
What came up, you mentioned like it spits out different sheets to run the different versions of Ubuntu. Is this like can I do this with my own project?
Yeah, you're doing it now, right? All you need, yeah. So I mean, GitHub gives this to you for free. As part of the certainly part of the academic license, but I think even if you don't have an academic license, it'll let you do it at some scale. I'm sure you just can't, mine Bitcoin or whatever, but um, yeah, don't do that. But yeah, it's all there and it's super easy. Yeah, I love it. It's really nice and something that is super easy for me to like integrate into the course too. Right now, you just have this YAML file and everybody's got it there. But yeah, you can use it on your own. Hmm. Okay, let's make this test pass. Actually, was that the only test that failed? I was kind of surprised there that handle the GPA in the main method. Why did this fail last time? 2 weeks ago. I wonder if there's another failing test. Oh yeah, it looks like invoke main test case. The integration test for student failed. So we might need to fix. I want to fix both of those. So if you don't mind, I'll take a little detour towards fixing unit tests or integration tests. So this project one IT, does it fail also? Nope, that passed. Okay, so that thing from a couple of weeks ago, I'm not sure why it failed then. Okay, so I'm not going to worry about that now. I do want to get this test though to pass. Um, Help me out here. What do I need to do to get this to pass?
It's like there is a double line of your pros.
Oh, yeah, yeah. I like that. Yeah, thanks for pointing that out. So when I ran the test in IntelliJ, and when the test fails, IntelliJ will underline, actually, it's in reddish. Yeah, in red, it's like, oh, yeah, here's what, this thing failed. Good to know, right? And it'll, yeah, and oh, yeah, here's like information about about the failure. And it'll let you run it under the debugger really easily. Great. I'm not going to look at that now because I think we pretty much know why it's not failing, why it's failing. So we need to make it pass. So basically, we need to say, hey, here in the constructor, if the GPA is negative, then throw that exception. So let's see here. How about we just make a check GPA? Well, I'm sorry, validate GPA. Great. And then we'll create that method. And we'll say if GPA is less than 0, I think that's all right. Less than 0. Resist the urge to like do that. Yep. Oh, gross. Okay, well, that is technically correct. I don't like it. I want to pass the GPA into the constructor here, and I do not want to assign the field. And so then I will create that constructor with the GPA, and then I'll say this dot invalid GPA equals GPA. And let's see here. This thing can be made final, as what it's telling me. Yep, because it's only assigned in the constructor, never changes, which is absolutely appropriate. And then back up here, what is it telling me here? Local variable exception is redundant. We can inline it. Sure. Inline the variable in the variable. That's nice. And oh, we've got a thing up here. What is it saying? GPA may be final. Well, make it so. Nice. We got rid of, oh, we still have a couple more warnings. Parameter classes and gender never used. Yeah, we're not there yet. Nice. I think that implements everything. Let's give it a try with our test. So we're gonna run. Nope, it still fails. Oh yeah. Expected a string containing invalid GPA -1. So I got to add that um to the message, which I can set in the constructor. So I can say, oh, thank you so much. That was helpful. We'll run this again. Nice, and it's green. And let's just run all of the tests. Everybody's green. So I really want to see it pass this time. I'm also going to oops. I'm also going to run it from the command line. Winter 20. Okay, and I'll just go to the student and run it there, and I'll just do a clean verify. Go. Oh, interesting. Invoke main student.it. This actually fails. Let's find out why. But first, I'm going to commit these, but not push them. I mean, I could push them, but it's just going to fail again. So I'm going to commit this change, which is throw an exception when GPA is negative. Just going to commit that. Won't push it yet. Now I got to figure out. That's funny. So like, why is it failing from? Oh, I didn't run the right integration test, did I? I ran project one IT from the phone bill, not student IT from the student. Yep, there it is. Oh wait, no tests were found. This is gonna be a problem. Yeah. Oh, yep, the test engine, this thing failed. Sorry, wait a second. So this happens every once in a while. I just gotta do a Maven clean, and that ought to take care of it. So sometimes when you go back and forth between running the command line, running tests on the command line, running tests in IntelliJ, especially the integration tests, for whatever reason, I don't know exactly why, you got to do a clean from the command line. And now when I run them again, I think it'll be better. Yes, it ran this time, and this one failed as expected. So here I ran this test, which I don't remember what this one does. Student name is written to standard out. So basically, it invokes main with the first argument of student, and it says nothing should be written to standard error, and standard out should contain string name. And instead, it got this uncaught exception in main, saying main method should not throw exceptions, which is true. Your main method should not throw exceptions, and it gets an array index out of bounds for for length 1. Oh, right. It's expecting a GPA. Well, let's just pass in a GPA. This will be a string, 3.14. Try this again. Oh, good. Now everything passes. I'm guessing we just weren't careful. I wasn't careful enough when we wrote this code, and that we didn't go back and run all of our integration tests when we added support for the now required GPA parameter. Nice. Okay. So now I'm going to commit that. And now I'm going to push things up to GitHub. Actually, I'm going to run it from the command line one more time. Oops. Verify. Sorry, it's a little hard to read. I'm going to put this up here so you can see the bottom of it. Run clean verify from the command line. I like doing this to serve as a sanity check. Great. That was successful. Now let's commit and push that code up. Yep, fix failing integration test. that needed to be updated. I don't know. Luckily, this course is not a course in writing commit messages that are effective. Good. Commit that and push it on up. And now we go back over here. We're going to go back to the main repository. And when we refresh, we see that, okay, great. That's the latest commit. And here is the changes that are in progress. So we'll just watch Java 24 here. Ah, boy. Okay. So now as Maven's doing its thing, it's downloading a whole bunch of jar files. Okay. Oh, looks like it's probably complaining about Java docs. This is a good sign. Oh, this might not be the right project yet. So normally it's just go on in the background, right? You'd like go have some coffee or like, go do your thing. Uh, oh, good. That looked pretty successful. Yeah, we got nice green check marks everywhere for JDK 21 and 24. And so now when we go back to the repository, yep, we've got a green check mark. Good. Everything's gone to green. And we got independent validation of it. That's the most important thing about the continuous integration is that, yep, while I ran on the command line, stuff like that, you've got an independent third party, basically, this clean room environment that tells you whether or not everything passed. And everybody can look at that and say, oh, yeah, right. We know what happened. We know that the artifact created by here is good because it's gone through all of the unit tests and things like that. So that's that part of continuous integration. Anything else that you'd like to know? Anything else that's on your mind or that we'd like to explore a little bit more? Nope. That's fine. In which case, hey, let's take a break. We don't usually get those. Let's take one. Let's take 10, be back at 6:31, and then we'll look a little bit more at what Maven can do. Okay, welcome back. Hope everybody's fresh, had a chance to like context switch, come back again. Um, we're talking about continuous integration tonight. We're talking about all the things you can do with the build. So we saw GitHub Actions and how they can be used for continuous integration and how they give you this feedback on your changes as they are committed to GitHub. It gives you an idea. It runs the test for you so that if you forget to, like I did, a couple weeks ago, it will tell you. Of course, I guess I also missed the email telling me that it had failed, but that's good. We drove it to green, and that's a good thing. We got a green check mark. That's awesome. Uh, there's something else you can do with Maven that I like to show off as part of continuous integration. They're not exactly related, but it's a cool thing that you can do with Maven. So, you've been using Maven to, oops, can I not scroll? Hello. That's not good. Hello. Come on. How come I can't scroll? That was weird. Yeah, you've been using Maven to build the project and to run the unit tests and all that kind of stuff, create the jar file. And Maven's great for that. But another thing that we can do is run a whole bunch of reports on your project. And this is kind of important stuff. So there are all of these static analysis. There's this suite of tools called static analysis tools. The whole thing, the whole idea is that it's called static analysis because they are run against your programs before it runs, before you execute it. So either it looks at the source code or it does some analysis on the artifact that was built, like the jar file or the executable or whatever, not by running it, but just like looking at the code or looking at the binary that's created. Boy, you couple like those stack analyses with like the output of your Java docs and then maybe some reports about the tests that you ran, and all of a sudden you've got a lot of information about your project. There are all these tools out here that can give you all of this, and Maven has a way to take the output of all those analysis tools and generate a website for it. And the whole idea here is that, hey, if you're running an open source project, you publish this website so that people can find your API documentation, so people can see the results of these stack analysis on your code so that they know whether to trust your code or not. So so you can find bugs and have people in your community fix them. So, what I want to do here for the next little bit of class is walk through how we can create one of these sites from our repository. Just to be clear, this isn't part of your grade or anything like that. You don't have to do this. But if you're working on your own project, let's say, hey, you're doing your capstone or something, and there's Java, and you're like, oh yeah, it'd be nice to have this stuff out there. It's something that can be done fairly easily with uh with Maven. So there's a couple of setup steps, and I'll get to the interesting stuff. Um, there's a Maven phase called site, which will build the website containing all of those reports. And there's a little bit of configuration that we need to do and just double check. So we need to make some changes to the pom.xml to get all this stuff working. So we're going to first look at the top level pom.xml. Okay, so here's the top level one. I'm just going to close these actually. Close all tabs and group. Yeah. So let's see here. There's some stuff oh yeah, that we want to change. So we got to change the yep, the group. So here's okay, this is the top level POM in the checkout. It's parent. So projects can have project parent projects that they inherit information configuration information about. Which actually in this course we use a lot because we create a lot of Maven projects. So the parent of this one is version 1.2.4 of my top level POM that we use for all the stuff in the course. And then this POM has its own group ID, which is just basically identifying the group, the people that produce the artifact. So this is going to be mine. So it's going to be I'm just going to have, let's see, my user ID is Whitlock. The name of the artifact is the joy of coding. And then there's also like the display name, et cetera, et cetera. Yeah, I think I want to change that artifact ID to Joy of Coding Winter 2024. Huh, I'm surprised that isn't that way out of the box. Okay. Anyway, no big deal that it's not, but I want to change it that way. So I've just modified the group ID and the artifact. The version is still 1.0.0 and will remain that way. For this POM, and now what I need to go do is for each one of the child projects, I need to go patch it up so it correctly refers to this parent. And what this does is that it'll just sort of weave everything together correctly. It'll also get rid of some warnings in the child projects. So I'm going to just copy this clipboard. The group ID is that, the artifact ID is that. I'm going to go into the koans directory with control click or with command click in my case. And oh yeah, look at that. The parent of this one is still my joy artifact. I don't want that. I want it to be this to be the parent, and then the version is 1.0.0. Oh yeah, looks like I need to, I can get rid of these because this is the same. What are they complaining here? Redundant? Oh, I guess I can get rid of those. That's neat. I don't think I want to do that though. Yeah. Now, when you make changes to pom.xml files, IntelliJ will pop up this little menu there. Sorry, that I accidentally clicked on. Pop up a little thing that will basically reload. It detects a change to the pom.xml, and by clicking that, it sort of synchronizes the information in the pom.xml with what IntelliJ knows about the project. And you can also do this manually by going to the Maven tab over here and either syncing all projects or just like reloading them, which kind of doesn't, not exactly a nuke and pave, but it deletes more of the cached information and rebuilds information from it. Over the years, I've often had students do this when their IntelliJ starts acting strange, like it can't find certain classes or doesn't know what doesn't know what JUnit's all about and things like that. So yep, it just kind of tell IntelliJ to start over again and resync everything. Okay, cool. Well, so that was that artifact for the koans project, and I'm going to do the same for student. Make sure, yep, its parent is all right. And the same thing for phone bill. Nice. And actually, this process is described up here. Oh yeah, how do I use the parent POM? So, because otherwise, yeah, you might get like this parent.relevant relative path warning when you run Maven. It's a warning. It's ultimately innocuous. But I'm annoying. Oh, it does. I do have the artifact. Good to know. That's exactly what I want. That's it. Cool. I've changed Maven stuff, so I'm going to reload. I'm going to resync Maven. Everybody seems to be okay. And I am just going to do a build from the command line just to make sure that everything fits together nicely, that all of the stuff is indeed executed. Yep, it was successful. Okay, so this was sort of a preparatory phase because the site will work a lot better when all the projects know who their parents are, and we'll see why. So I'm just going to commit these changes. Patch up the parent-child relationships. Okay, apparently we're in a family therapy class now. Between Maven projects. Okay. Okay, now that we've done that, let's go back here and scroll back down to creating a website for this. So ultimately what we're going to do, I don't want to give away the surprise, but we're going to create this site and we're going to use a feature of GitHub called GitHub Pages that allows you to host static HTML content or static content on the web via GitHub. So we're going to do that now. So let's see here. Right. So we're going to go through, we need to create a branch called gh-pages. This is the GitHub convention for saying, hey, whatever content is on this gh-pages branch of a repository, GitHub will make that publicly available over the internet. That's the way it works. It's kind of a nice feature. First you got to do is you got to create that branch. We will check out the repository. So we're going to like switch to that branch in GitHub. For whatever reason, if there's a readme.md that is served up, I don't want the readme to be served up. So I've got to delete it on this branch. And and by the way, let's just double check. Yep, really? Yep, we are on the GH pages branch, not main. We deleted that. We're going to commit the removal of the readme.md to that branch. We are going to push, and we're going to create an upstream origin branch in the GitHub repository that pushed it up. And now we're going to go back to our main. So there's just a little bit of setup code that basically gets us that. It gets us the GH pages branch. And actually, if I try to go to, let's see here, this URL, HTTPS, it'll be David Whitlock, which is my GitHub ID, .github.io, I want to say. Yes. / Joy of Coding Winter 2026, which is the name of my repository. Then, okay, it's giving me a 404, but I don't really have, yeah, it doesn't have an index.html yet. So, okay, so I guess there's nothing here yet, but very shortly we'll put something there. Okay, so we'll just keep that tab open because we'll reload it later. Okay, I think there's a little bit more stuff that we need to do to our pom.xml to make it so this will work. So let's see here. Before you do this, you must replace instances of your GitHub user with my GitHub user in the top level pom.xml. So let's go to the top level pom.xml and then say your GitHub user in lowercase. That's David Whitlock. And let's find that again. Your GitHub user down here. This is all, well, we'll walk through this, I guess, a little bit. And then we'll find the F3, no, F2, no, what's next? What's find next? Geez, I should know that. Okay, GitHub user is, boy, maybe I should have done a search and replace. Sorry. Yeah. Okay. And then, oh, yeah. Okay, cool. So, okay, I replaced all that stuff. Okay. So basically what I'm telling it, and you can do the same, is I'm telling I'm telling Maven, hey, telling Maven about my use of GitHub. Okay. I can't remember if we talked about this yet. We probably didn't. So, uh, the pom.xml has all sorts of information about your project. I mean, a lot of it is related to how it's built. Oh, here's which version of Java that you use. Oh, yeah, by the way, I depend on JUnit. Here's the version, right? All that stuff important for it to build. But it also has information about not so much how to build a project, but like the project itself. Like the developers section, right? We saw that in the katas. We populated that with the people who developed the project. And other information. So like, hey, here's information about what the license is. Here is information about who produces it. At Portland State University. Here's information about what Maven, sorry, what yeah, Maven repositories, which artifact repositories to use. And then there's some other configuration about like the Maven site plugin and stuff like that that all need to know, hey, like, hey, what is the SCM? Oh, sorry, what's the Git URL for this? And yeah, it's from me. It's in my organization, just the same way yours would be in your organization. So I think I've gone through and done all of that. So now I'm going to say specify, yeah, the GitHub user for this repository. And by doing that, then now when I generate the site for this project using Maven, it'll generate correct reports. So I'm going to do that by running Maven W site. Actually, let's make sure that's the right one. Yeah, the first one is site. So what Maven site does, so when we generate a site with Maven, it goes through and will build your project, and our projects are configured to run a whole bunch of reports. Now, some of those reports, as I was saying earlier, have to do with the results of your automated tests. Some of them are your API documentation that's created, and then there are other plugins that we'll see here in a moment that talk about the project itself, like, hey, who are the authors? That will tell you things about the third-party libraries that are used, all sorts of great things. So it did all that. That's cool. And so this generates actually in the target directory. So remember, target is where all of the built artifacts are, like your class files, the outputs of running your tests, all that kind of stuff. Now it has a site folder, and inside site is all this information, a bunch of HTML files. There's some of the stuff comes from like, here's your API docs, all this good stuff. For whatever reason, the layout here, you can't open it and see it very nicely. Instead, in order to do that, you run the stage goal of the site plugin with Maven W site stage. And what this does is it takes all that stuff and puts it in a nicer location. And now we can open up this index.html in the staging directory, staging index.html. And so here is the generated documentation from the project. And this starts with a top level view. It's basically like stuff from your POM files. And so then by default, it says, hey, listen, there are these sub-modules. So here's some documentation for your koans, for your student, and your phone bill. You can get information about like, hey, here's the license that's used here. Our stuff is licensed under Apache. You can find out about the dependencies here. And so it'll tell you like, hey, listen, there's one compile dependency, this Guava library, which actually is inherited from the POM. You probably didn't realize it did that. But like, here's the versions of Hamcrest and JUnit that you're using. And then here are the transit dependencies. So these are the dependencies that your dependencies depend on. But what it tells you is here's all of the third-party software that's being used in this project. And this is incredibly important information because it speaks to what's called the software supply chain, right? Everybody, Probably everybody knows what supply chain is now. 10 years ago, no one, only manufacturing people heard of a supply chain, right? The whole idea is that just like, boy, a manufactured product or food, there are lots of, like the better word, hands that touch the constituent parts, right? So when you eat your McDonald's hamburger, right? As an example, also there's also ingredients that went in there, and you want to know ultimately that that hamburger comes from someplace that's safe. And so then this is why we have USDA that makes sure that, like, yes, the cows are safe and healthy, and that the meat processing plant is has the appropriate controls in place, and all the food handling, all that stuff like that. There's the same concept in software, right? Especially, well, with open source. Because let's face it, open source is stuff out there in the internet. How do you know it's any good? And you better believe if someone's paying you for your software, you're gonna get to a point where they're gonna say, "Hey, listen, if in order for us to meet your asking price, you're gonna need to tell us that your software is safe." And so then it's very, very important to know the pedigree, the constituent parts that all went into your software. And so this is a great thing about Maven, is that because all the dependencies are called out in pom.xml files, and pom.xml files are publicly available, there are tools like this that can tell you, oh, here are all the constituent parts, here are all the pieces parts, here's the versions of them. This is what ultimately, the customer is deploying in their environment, or what that you're using internally. And of course, by making this information available, your customers know that hey, you're using the latest version of something, or oh, maybe you're using a super old version which is known to have vulnerabilities in it. You better upgrade it. Anyway, all sorts of great stuff in these projects, and it all comes for free. I guess that's basically free, right? We configured our project one way, we ran these tools, and you get all these reports. So there's information you can get about the project, and you can dive into other reports here, and this is where you can get your API documentation. So here's the API documentation generated for all of this, and so then we can look at, like, here's the phone bill and the student class and everything. We saw this the other day, the generated API documentation for, like, the constructor and things like that, with all of this information about the student. And you can navigate off to the official Java docs. So if you want to know what Java lang string is, again, Maven makes all this possible to be able to do all of that. What else? We've got API documentation. We've got some other cool things, some analyses. One of my favorites is the we only have it on the child project. Where is bugs? Okay, well, anyway, there's stuff I can tell you, like let's go look at the let's go look at phone bill. Let's see here. And on the project reports, yeah, here's where it has, like, your code coverage. So you can see out of the box, I've only got whatever that is, 65% code coverage. And you can, I'll make it a little bit bigger. You can drill down into specific classes, and oh yeah, right, here's that phone bill DAO. Oh, nothing calls the main. Okay, good to know. I'm glad you asked about that, because yeah, this may be a problem. In which case you can probably just comment out the main method, and I think it'll be okay. Yeah. Why does this have a main method? Oh, but you can go to the source code this way. Oh yeah, look at that. Okay. Huh. I should probably write an integration test for that then. Yeah, I should run an integration test for that. Okay, good to know. Yeah. Yeah, and so you can get information about the code coverage that way. Spot bugs is also one of my favorites. It goes through, and there's this database of well-known potential bugs, smelly code or potentially dangerous code that it will tell you about. Oh, look at this thing. Okay, so the phone bill DAO may expose internal representation by storing an externally mutable object into phone bill DAO.connection. Well, that's interesting. So let's go look at what line of code that is. Oh, did it not find it? Oh, okay, that's a little messed up. Okay. I wonder why that didn't work. Okay. But then, like, it'll tell you, you can find out more details about that particular error. What is that? EI expose rep 2. Rep 2. There it is. It didn't link exactly right to it. But yeah, you can find out, about like, oh yeah, this is like some dangerous stuff that you're doing. Maybe you should reconsider it. Um, and again, it comes for essentially free. Really powerful stuff. So anyway, you've got all of these neat reports and other things that you can see. You can also see like the results of your unit tests. And again, for this project, pretty simple, but you can imagine you have like a really big project, a really big open source project, or even something, that's internal to your organization. You can get all of these reports and you can then, find out, interesting things about your project. Again, have the robots do it in the background for essentially free. So you've got these reports, and I was running them locally from the staged environment. Oops. And then the last thing that you can do is publish it up to GitHub. And so the way you do that is there is an SCM publish plugin that we use. So I hope it works. And so actually what this does is it goes through and takes your site and commits all the HTML files to the GH pages branch of your repository. Okay. And maybe push it up there. Okay. Let's find out. So now if I go back to my github.io and I reload, oh, bother, it didn't. So let's see here. Looks like it was okay. Do I need to push it or something? Let me just make sure. Nope, it should have worked. Oh, maybe it didn't work this time. So I'm going to go to GitHub. I'm going to go to the, oops, reload here. So it sees my GitHub pages. Branch. Oh, there should be an index.html. So I wonder if I have the URL wrong. Oh, it just took a moment. Okay. All right. Yep, I was too much of a hurry. But now, okay, so note the URL, right? This is out there on the internet. Oops. And so it was that easy just to take all of that HTML that I generated, all the reports, stuff like that, and now it's up here. And so now we can, basically, this is us publishing our source code, our information about our Maven project. And actually, so something that we can do here is we can again look in the Java doc for our student. And oh, look, it even like links off to my project. So this is not code. This is the human class, which wasn't in the Winter 2026 project. This is off in my my Joy of Coding general repository, and can link off here too. So bottom line is that this is like a really powerful set of tools that Maven offers. So it's not just about building your code and running your tests. Like, oh, you can run all these reports and generate all this information about your project, which all this was developed, for the open source community. But it just works with Maven, and so you can use it on any project that you want. What do you think? Anything else you'd like to know? Anything else that's curious to you or that you'd like to discuss? Yeah.
Run Maven site once in the parent file. We don't need to do it in like phone build.
Great question. Yes, that's correct. When you run Maven site in the parent directory, it will recurse and do the ones in the child project, just like when you run Maven clean verify, right? So the way Maven works is that when you have these parent-child projects, you run the Maven command in the parent, and it'll apply to all the child projects, which is sort of the intent of what you want, especially with something like clean verify. Yeah. Nice. Anything else I can tell you about what we've seen tonight so far with the Maven, with the continuous integration? Yeah. Nice. Okay, well, let's finish off by, oh, sorry. Well, let's finish off by talking about project 3. I know you're still working on project 1 and project 2 is a little off, but I want to give you an idea of what's coming next, and so that you can plan accordingly. This isn't due until February 11th, which is that only 2 weeks away? Gosh, it might be. Oops. Yeah, wow, okay, time's flying. Well, sorry, 2.5 weeks, 2 weeks and 2 days, because it's due on Wednesday. Okay. So project 1 that you're working on right now, you're doing, your very fundamental things. You are just, authoring your phone call and phone bill objects. You're parsing the command line. You're not doing much of anything interesting, right? Maybe printing out its two-string value, which is the whole idea of project 1, right? Baby steps here. Get used to, building more complex projects, writing unit tests, dealing with the main method, all that kind of stuff. Project 2 got a little bit more interesting, a little bit more capability to your program. You can read and write from text files. And so then you'll need to figure out how to, create a format for your phone bill that can be written out to a text file and then read back in. Project 3 augments Project 2 by adding the ability to pretty print a phone bill. And this gives you an opportunity to work with Java's facilities for formatting dates and times, and also for sorting information. This is all covered in the lectures for tonight's class on the collections API and working with dates and text format. So I'm going to talk about some of the things that need to be done for this project. As you may recall, abstract phone bill has get begin time and get end time in addition to the get begin time string, get end time string. You can ignore them for the first two projects. Well, now you're going to use them. So now I'd like you to override get begin time and get end time to, instead of returning null, which is what the abstract superclass returns, instead have it return instances of Java time, local date time. And in those lectures, you can learn all about what the Java time API is all about and what local date time is. Another thing I'd like you to change is the implementation of get begin time string, get end time string. Probably what you're doing right now is just saying, hey, whatever string was passing from the command line, send that through. Instead, now that we have the dates and times represented, the begin time and the end time represented as a local date time, an actual object that represents a time instead of just a string, I'd like you to format that local date time object using format style.short. Again, that formatting is covered in the lecture. So you're making some changes to your program. This is a very natural thing to do, right? You're doing more and more with your program, and so now it's going to have some, it's going to do the same thing but in a slightly different way. New requirement on phone calls. So where probably in project 2 you stored the phone calls in whatever order they were entered in by invoking the program multiple times. Now we're going to add the ability to sort phone calls chronologically by their begin time. So one of the things in the lectures, it talks about something called the comparable interface, which sorry. There it is. The comparable interface, that when you have an object or class that implements comparable, it knows how to compare itself to something else. And so now we're going to make it so that phone calls know how to compare themselves to one another so that they will naturally sort themselves chronologically by their begin time. And note that if you have two phone calls that have the same begin time, then sort them by the caller's phone numbers. And then anything that has any two calls that have calls that begin at the same time and by the same caller, let's consider those the same. Those are considered equals when it comes to the comparable interface. Also in project 3, there will be a new kind of phone bill dumper. Phone bill dumper was introduced in project 2. It is an interface that takes a phone bill and dumps it to some destination. In project 2, it was a text file. Now in Pretty Printer, the Pretty Printer class will be a phone bill dumper that formats the phone bill and its calls. Not in a format that can be read by a machine, but one that's meant to be read by a human. So you'll have things like, spaces in between things and in between words, and it will use date formats to make the dates look nice. And in the pretty format, the calls that are in a phone bill are sorted in the order that I described up here. So this is where we validate that the phone calls are ordered first, are ordered chronologically by their begin time and then appropriately when multiple calls begin at the same time. So again, please use something like date time formatter to have dates that look nice. And that note that the pretty output should also include the duration of each phone call in minutes. So a new requirement there. So because there are some changes that you need to make, right? We're working with real dates now, local date time objects, not just strings. We're adding some new functionality to phone call. They can sort themselves because they implement the comparable interface. And then there's this phone bill dumper that formats the calls in a phone bill in a way that a human can read, not a machine. And to be clear, there is no printer parser. You don't need to be able to parse the pretty output. You've got the text file for that. And all this functionality is driven by a new main class called Project 3. Again, I recommend that you take your Project 2, just rename it to Project 3, and go from there. Has all the same capabilities as Project 2 with some notable differences. The format of the dates and times, well, the format of the time has changed on the command line. So it's not 24-hour time anymore. Now it's 12-hour time with an AM and PM. And note that whereas in projects 1 and 2, the date time was 2 command line arguments, 1 command line argument for the date, another one for the time. It's now 3, because now you've got the date, the 12-hour time, and the AM PM indicator. Additionally, you've got a new option for Project 3. You still have the same 3 options from Project 2, the README, the dash print, and the dash text file. Now there's dash pretty. And dash pretty has the following semantics. When dash pretty is present, the pretty content, the pretty version, pretty representation of the phone bill that's being managed is written to a text file. Or if the name of the file is dash, so if you say dash pretty dash, then the pretty format should be written to standard out. That's kind of a Unixy thing, right? If you say dash, it'll write it to standard output. Otherwise, the semantics of the program are the same, right? Every time you invoke the program with valid command line arguments, it adds a new phone call to the phone bill. If dash text file is there, it ought to read the contents of the text file if it exists to initialize the phone bill before you add the new phone call to it. Footnotes here are worth reading, but I'm not going to read them to you now. And finally, just some notes on some errors you might want to handle. Obviously, if the command line is messed up, basically all the same kind of things you need to worry about in Project 2. And of course, with the format of the data time changing for Project 3, you need to be sensitive to that. Oh, and there's also a new requirement. Now that we're dealing with real dates, it should be an error to have the end time for a phone call be before its begin time. I don't worry about time zones. I did time zones 1 year and it was a debacle, so I forget it. We'll just assume everybody's in the same time zone here. And finally, to submit this, use a submit script with Project 3 from one of the Linux machines from the CS department. So there's a lot, and we haven't broken ground on Project 2 most likely, but I wanted to show this to you now because we've got time in class. I want to make sure we can have lots of time on Wednesday for pairing. But what else would you like to know? Was there anything here that immediately jumps to your mind? It's like, oh, what's this thing all about, or what do you need to know? Yeah.
At daylight savings time, I think you're getting called maybe.
Let's not worry about daylight savings time either, right? Time zones, daylight savings time. You're right. Real world, absolutely to think about these things. There's enough here. Yeah, no kidding, right? Yeah. But good for asking, right? I mean, that's sort of the mindset you got to be in, because I'm sure there will be some things where you're like, he's definitely not going to test that, and then he says he tested that, damn him. And it's like, yes, and then I'm damned. Great. Anything else you'd like to know? Cool. Okay. Again, happy to take questions on this as they appear. And listen, once project 2 is, squared away, I'm sure there'll be some things that come up. Happy to answer them there also. But here again, want to give you an idea of where we're going, so that you can plan your time accordingly. Okay. And that is it for tonight. On Wednesday, we'll be doing our second pair program activity. Please be here in person. Bring your HDMI adapter if you got one. Can't wait to see you then. Thanks, everybody. Bye now.